Hi class, let's take a look at example 6. And if example 6 happens to have a messy graph, I would give you the sketch of it and then also tell you the, where we're actually integrating. And the t is equal to negative 2 to 1 actually represents this portion. I'm providing a sketch here of what it looks for larger values of t or t's that happen to continue to be negative. And for the actual area, so the actual area, we're going to be evaluating the integral from negative 2 to 1. This is given in the bounds of integration. And then we're going to have the t to the second plus the t plus 1. The formula uses the x prime, so t to the third minus 3t prime dt. So it's going to simplify to negative 2 to 1 of t squared plus t plus 1 times 3t to the second minus 3 dt. So 3t to the second minus 3, t squared plus t plus 1. Let me carry this FOIL on the side, and then we'll just clean up the actual integral. So this is a t squared plus a t plus 1 times a 3t to the second minus 3. And as we multiplied the t squared, we're looking at 3t to the fourth power, and then plus a 3t to the third plus a 3t to the third, and plus a 3t squared. So plus a 3t squared as we multiply. Oh shoot, hold on. Let me, I'm going out of order here. So 3t to the fourth and then minus 3t squared. So minus 3t squared. Then I'm going to multiply the t times those two. So it'll be plus a 3t to the third minus a 3t, and then technically plus 3t squared minus 3. Okay, so let me collect like terms. And let me double check. So 3t to the fourth minus 3t squared plus 3t to the third minus 3t and 3t squared minus 3. So let me rewrite the integral and simplified. So this is negative 2 to 1. Highest term is going to be the 3t to the fourth. So 3t to the fourth. And then t's to the third power, I have 1. So plus a 3t to the third. So this one is to the third power. And then to the second power, the second powers cancel. So I just have a minus 3t minus 3 dt. And let me check all the terms, but I think we're good. Because technically these cancel. Okay, so let me evaluate the integral, and it's going to turn out to be a little bit messy on the next step. So our integral is going to be a 3t to the fifth divided by 5 plus a 3t to the fourth divided by 4 minus a 3 squared divided by 2 minus a 3t evaluated from negative 2 to 1. Okay, so let me just put parentheses, and let me actually evaluate these on the side. So because I see the messy fractions, well, it's not going to get that messy, but to not mess it up. So for t is equal to 1, we're just going to have, well, 3/5 times 1 to the fifth plus 3/4 times 1 to the fourth minus 3 halves times 1 squared minus 3 times 1, or simply 3/5 plus 3/4 minus 3 halves minus 3. And let me just combine these into a single fraction. So our LCD here is equal to 20. So times 4 times 4 times 3 times 10 and times 20. So just this portion, it's going to give us, so 12 20s plus, this is supposed to be a 5, plus 15 20s minus 30 20s plus, actually wait, the last one is a minus, minus 60 20s. So let me double check. Okay, so evaluating the 1, let me simplify this one. So we're just going to get 12 plus 15 minus 30 minus 60. I'm getting negative 63 20s just for that portion. And let me double check that value. Okay, so let's evaluate now at t is equal to negative 2. So t is equal to negative 2. So this is going to be, let me put a parenthesis there, 3/5 times negative 2 to the 5th plus 3/4 times negative 2 to the 4th power minus 3 halves times negative 2 to the 2nd minus 3 times a negative 2. And remember that this portion is, it's the lower bound limit. So let me double check. 3/5 negative 2 to the 5th power, 3/4 negative 2 to the 4th, negative 3 halves negative 2 squared. Okay, we're good. And this is actually going to simplify to, well, 2 to the 5th is 32. Let me double check that. 32 times 3. I'm getting for the first one 96 fifths. And then the second one, it's going to be plus 3/4. And then 2 to the 4, it's going to be 16. And then minus 3 times 2 times 4 plus 6. So this is going to give us still the 96 fifths plus the values of 3 times 4 minus 3 times 2 plus 6. So this is giving us 96 fifths plus the values of 12 minus 6 plus 6. So this is just 96 fifths plus the values of 12. And let me express them as, let's see, yeah, let me express it as fifths. So this will be over 1, and then the LCD is equal to 5. So times 5 and times 5. And this is giving us 96 fifths. So 12 times 5 is 60. So plus 60 fifths. So 96 plus 60, 156 fifths. Okay, I found the mistake. So the mistake was here. This is negative, that's negative, that's negative, which changes this to a negative and changes that to a negative. So this is going to give us instead, so negative 96 plus 60, negative 36 fifths. Okay, so the final answer. It's going to be negative 63/20 minus a negative 36 fifths, which is equal to negative 63/20 plus 36 fifths. So using an LCD of, well, 20, so multiply times 4 and times 4, and we're looking at negative 63/20 plus 36 times 4, it's 144 20s. So 144 minus 63, I'm getting that this is 81 20s. Okay, now we're matching to what I had. So the final answer, or in this case, the enclosed area, it's going to be equal to 81 20s units squared. So the messy integral ends up simplifying, and let me put this in green, to negative 63/20 minus the negative 36 fifths. Which happens to end up being a final answer of 81 20s. And I just wanted to put it here because technically we went to the side. So here's the final answer. And it was kind of messy as we were plugging in. It was just the fractions. And then also I messed up that negative that threw everything off. That would be it for this one.